Today we're going to look at the quadratic formula. So if we look at a quadratic equation in standard form, then we're going to be able to use a specific formula in order to solve this quadratic equation. It's important for us to remember where our A, B, and C are, and this is called our standard form. So in order to solve these equations this way, we're going to always have to put them in standard form. So this problem says to state the values of A, B, and C. You might be able to just look at it and figure out what A, B, and C are, but let's go ahead and remember our standard form is ax squared, that's really sloppy, ax squared plus bx plus c. So let's go ahead and put this in standard form. Let's move this over, because we already have an 8x minus 4x, because we had to subtract, and if we move this over, it's going to be plus 11. So now we have an A, B, and our C. Don't forget that negative that's in front of the 4. Okay, when you're solving these quadratic equations, you need to put them in a form where they can be where you can complete the square. If you look at example 1 on page 502, it will go into more detail as to how they got the quadratic formula. But the quadratic formula goes like this: x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And you just plug in your a, b, and c numbers from your original problem. So again, here's our theorem. A cannot equal 0 for this to work, because then it would make it be 0 times x squared, and that would go away. So this is our quadratic formula. And it's really important that you remember this. Write it on your notes, write it on the board, whatever you have to do in order to make it work. So let's actually solve a problem using this. Whenever we're going to solve a problem, we need to make sure it's in standard form to begin with. We are starting off with a problem that's in standard form. We don't have anything in front of our x, so it's a 1. We have that pretend 1 there. And remember, our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You will need to have this memorized, so you need to be studying this. So if we use our quadratic equation, this is our A, this is our B, and this is our C, we can plug everything into this formula and we can solve it. And our A equals 1, our B equals 5, and our C equals negative 6. So let's continue working this. We're going to go ahead and plug in our numbers. Notice where all the B's were are now 5s, and where the we have our 4 that always stays there, and then we have a 1 where the A goes and a negative 6 where the C goes, and our 2 always stays here, and we have a 1 where the A goes. And if we go ahead and work that out as much as possible, we end up with Negative 5 plus or minus the square root of 49. We know that 49 is a perfect square, so that makes it turn out nice and easy. So we have negative 5 plus 7 over 2, or negative 5 minus 7 over 2. So we're going to have two different answers. And either of those answers are acceptable, and you write them like this because this is a set of solutions for this particular problem. So we write them as a set. Okay, so to recap our steps, we write the equation in standard form so that we can pick out our A, B, and C. We figure out which ones are our A, B, and C, and then we substitute the values into the quadratic formula. Let's look at another example. Now this one is not in standard form, so we need to put it in standard form. We have 3y. Y doesn't matter. It's just the variable. It could have been x. It doesn't matter. Minus 4y, and then in order to move this over, we have to subtract 8. So this is our A, this is our B, and this is our C. So let's go ahead and plug those numbers in for our quadratic equation. One thing that I want to point out here is that we have two negatives here, so that's going to make that be a positive 4, because we have a negative already in our original formula, and our B was a negative 4, so we have negative, negative 4. And also, when we square this negative 4, it's going to turn into a positive. Here we have a negative times a positive, which is going to be negative, but then that negative times a negative is going to make it turn out to be a positive number. So it's really important that you pay attention to your signs so that you know if your numbers are negative or positive. So we're just going to continue simplifying until it's as simplified as possible. Now, you might think this is a perfect square, so I can go ahead and solve it, but it's with this. So we have to solve all of this before we can deal with our radical. And whenever we simplify 112, it's not a perfect square, but we can take 4 out of there. And so we're going to have 4 plus 4 times the square root of 7 over 6, or 4 minus 4 times the square root of 7 over 6. And whenever we can actually factor out a 2 out of both of those here. And those 2's it's kind of like cross multiplication. You can factor things out. You can factor a 2 out of here, and you can factor a 2 out of here. And you can go ahead and reduce, or you can reduce later. It doesn't matter. So we have 2 plus 2, or 2 minus